First of all, good day. My name is Paul Joss. I'm the Director of Sales and Marketing here with AccuCheck Measurement, and I'm joined today by my colleague Greg Sepio, who's our Director of Technology Development here at AccuCheck. And our topic today is a very specific one. We're going to look at the utilization of AccuCheck technology for inspecting small edge features on precision machine components, which in our world usually means the rotating components of gas turbine machinery, but not exclusively, really. Anybody who's doing precision machining that's having to do edge treatments like chamfers and radii, or even just deburring an edge to break an edge, has done a lot of type of equipment for reducing stress concentrations and for safety and for fit and function. So anybody's doing that will find this relevant. So that's our topic today. We're going to try to keep it tight right at 30 minutes or under, so I'll apologize in advance for talking too quickly, which I tend to do naturally anyways. But our agenda is pretty straightforward. I'm going to do a brief discussion about the application, just a brief overview of the AccuCheck technology and the application. We're going to turn it over to Greg. He's going to demonstrate both the handheld and the automated versions of implementing our technology for this particular application, and then we're going to wrap it up with a little Q&A at the end. Just a couple of things to mention is that everybody's going to be muted, so for the Q&A, you're going to want to type into the little chat box for the Q&A box, and you can ask your questions, and we'll see them and be able to answer them at the end. Also, when we get to the point of the screen share where Greg is showing both the camera of the measurement as well as the screen, you can click back and forth to enlarge whichever one is of interest to you at the given time. So just a little heads up on that. So. All right, we'll get going by way of introduction. I want to first introduce AccuCheck Measurement. We are a US-based company located in Swarthmore, Pennsylvania, just outside Philadelphia. We've also got an office in Grand Rapids, Michigan, and we are specialists in optical measurement and inspection. So this means everything we do entails taking cameras and software and putting them together to address some sort of a manufacturing challenge, usually at the intersection of need for productivity and quality control. So we work with manufacturers across North America to help them achieve, the efficiency and productivity that they need to be competitive, and utilizing 4 different technologies. So we're going to be talking today about the GapGun Pro down here in the bottom left, but I'm also going to just briefly touch the other products that we cover. One is the Lynx system, which is an automated visual inspection system. So this is a machine vision system aimed at error-proofing of large, complicated assemblies. So think of aerostructure or truck chassis and things like that. We're just checking to make sure things have been assembled properly and looking for any errors, like something is missing or placed incorrectly on the part. So that's the Lynx system. We work with the Tube Inspect system, which is an optical gauge for formed tubes and wires. So people doing CNC tube bending of things like brake lines and fuel lines in aircraft or bus bars for electric vehicles. These things have to be controlled, and our tools work with that. And then we also work with the fastener measurement tool, which is really a purpose-built handheld 3D scanner that is focused on countersink and fastener flushing measurement, primarily on aircraft. Okay, so that's the little niches in which we operate there. But today we're going to talk about the GapGun, and what the GapGun is, it's a laser profile gauge. It's based on the principles of laser triangulation. So if you look at this graphic on the upper right, we've got a laser line projector projecting a line onto a surface, and the camera at a calibrated angle at a fixed angle is going to take a picture of that image. It's got a calibrated measurement volume so that we know the spacing of every pixel in there. So when we get this little 2D image, you can think kind of like a section cut through your real world part that you're comparing to CAD. We can take that section cut and extract very precise dimensional information out of it. So if you look at this image at the bottom, so on the bottom right, you've got the GapGun measuring a chamfer, and then the image you're going to see where the red is, this is an image from our software called SPC 3D. There's the red is the laser line, and then the blue is the material side of the feature, and then the numbers are the numerical values we've extracted, in this case the leg lengths and the angle of that particular chamfer. So that's kind of the basic principle of the GapGun, and its function or reason for existing is that really the GapGun is here to really replace older methods of performing these types of gauging. So anybody who's producing these types of machine components and making these edge treatments has got to do some sort of control. So either using hand tools or coordinate measuring machines or optical comparators, or a number of different ways of doing that. And what the GapGun offers is a very fast, very accurate, super easy way of making these inspections right there on the shop floor where the production is being done. So if we're not replacing these methods, we're at least offloading a tremendous amount of the work onto the GapGun to be able to do it more efficiently. Okay, and as a point of comparison, a lot of our customers, not exclusively, but a lot of places will go into to talk about the GapGun. What they're doing today is what we call the cast and compare method, where they're mixing up a compound, kind of like a repro rubber type of compound that they mix together so it'll start curing. They're going to place it and onto the features that you want to measure and let it cure so it'll harden. Once it hardens, you're going to peel that back off of there and then slice it, because now it's going to represent the shape. You're going to slice that, take that little 2D slice, put it on an optical comparator, and on there you can extract the dimensions you want. So whether it's using the software built into the optical comparator or typical template type of approach, you can get the measurement. So it's not a bad way of doing it, but it's well proven, but it's also tends to be fairly slow. So you're looking at minutes, 15 to 30 minutes per feature to go through this process. And if you look at just a typical turbine disk, you're going to have dozens of things you've got to check on there. So it becomes a bit of a bottleneck. GapGun, turns that on a head and has a very simple two-step process for performing this inspection. You're going to position the GapGun, you're going to pull the trigger, and within 2 to 3 seconds, you've got your answer. Okay, so again, in this case, we're looking at the screen of the GapGun. So right there, the operator is seeing, there's my chamfer measurement, there's my leg lengths and my angle, and my intolerance or not, that quickly. So that's really what the GapGun brings to the table. So when customers are looking at transitioning from the traditional methods to the GapGun, their motivations are some combination of these 3 factors. So first and foremost is usually speed, right? So because the GapGun is so fast, I can make these inspections. I can either do more inspections, inspect more parts or a larger number of features, or I can do the same inspections but just a lot faster to improve my productivity and eliminate the inspection as a bottleneck in the process. So speed is number 1. But number 2 is confidence. And the beautiful thing with the GapGun is that a lot of times in life, if you're going to do something faster, you have to trade off quality to get that speed. But the GapGun, you don't have to do that. We're measuring much faster, but we also have ways built into the way we measure with the GapGun to ensure high confidence in those results. First is that when we have this profile, we're going to specify exactly how I want to extract the measurement. So in this case, we fit a couple lines and we're fitting a radius to the arc between those to come up with that radius measurement. So you can specify how you want to make that measurement. So it's done the same way, no matter who pulls the trigger. Secondly, when we make a measurement with the GapGun, it's not just a single measurement. We actually pull the trigger. We're taking multiple images, say 6 sets of images, performing that inspection independently, performing statistical analysis, and then giving you a composite, an average result of those all in those couple of seconds. So it's as if you did that optical comparator thing, say 6 times through, is what you're getting with the GapGun in just a couple of seconds. Finally, there's the efficiency of the GapGun. So it's a standalone, fully digital device, so nobody's writing anything down or typing anything in. The GapGun is on its own out there, no computer attached, just performing the measurements. Operators can follow the work instructions on the GapGun as to what to measure. And when you're finished, you can just simply transfer that data back to the host computer and put it into your ecosystem, whether that means the quality management system or Excel reports or anything like that. So that's what you get with the GapGun. The GapGun Pro2 packaging is really, really designed to be efficient, ergonomic shop floor measurement. So it starts with the namesake pistol grip with the trigger for making the measurements. A simple pull of the trigger. This T15 sensor we have on the end is a very high resolution sensor that we've got just over a ½ stripe with over 2,000 pixels in there, where we're able to get very high resolution imaging on the features we're looking at. You can use the GapGun with the sensor attached or with the extension cable as shown here. There's the color touchscreen interface for the user. So just everything built to make operators want to use this thing on the shop floor, and it's all done with an ISO 17025 certification. So the GapGun is coming with that out of the box, so you can be confident in the measurement results. When we look at automating the GapGun, we really use those same components, the same sensing, the same processing. We just have ditched the pistol grip, and we're going to mount this to a robot. So we're going to take the sensor, place it on a robot, and this is for applications where I'm going to be inspecting it at a high frequency. Maybe I've got to inspect the same part again and again all day long. Or maybe I've just got the tightest tolerance. I want to make sure I'm getting the highest level of repeatability. So that's what the GapGun entails. We just automate the process. The measurement itself is the same, but running it is simple as hit the button and tell what to inspect, and the robot will do the work. So We've got plugins for both FANUC and UR cobots, and it can also be integrated with just traditional industrial robots. Okay, so the last thing I want to mention before I turn over to Greg is that, in addition to the hardware packaging, on the software side, there's some real power within the GapGun software to make sure that, as I said, you can rely on these measurements as rock solid. So within this software, it's called SBC3D. This is the management software of the GapGun. So it's not something that operators are using on a daily basis, but this is how I specify. How do I want to measure? I want to fit a line. I want to fit a line. I want to fit the radius between it. So I'm going to fit these mathematical primitives to the laser line, and I define how to do it so that it happens the same way every time, very repeatably. Same thing with a chamfer down here. I can specify how I want to fit lines to it. How do I want to extract the angles, and which sections of the line do I want to use for that measurement. So very, very robust for that type of measurement. But there are some features, as I mentioned earlier, where you're just deburring an edge. It may not be a real radius or a chamfer, just is not a sharp edge anymore. So we need to be able to check that as well. So instead of trying to fit a radius to it or a chamfer, we just say, hey, does it fall within the maximum zone? So you've got these, upper spec limit and lower spec limit, which could be a line or it could be a radius. And basically, if the profile fits between there, it's good to go. We pass. If it's outside for any reason, maybe there's some overhang, maybe it's got a bit of a gouge in it, then that's going to fail, and the GapGun's going to detect that in the inspection. Okay, and within the software, we've got these tools, edge break tools, that really allows us to define these regions of interest, to set up profiles to eliminate the potential for false negatives. So really, all the tools in the software are built in to make sure that when I'm using this for these edge features, I'm getting very, very robust and reliable measurements. Okay, and so that's the part I wanted to go over. I know it was quick, but we're going to send everybody the recording afterwards. And I'm going to turn it over to Greg so he can go through and show you this in operation. And again, just remember, when you get to the part about you're looking at the screen, you can click which you want to see, the close-up of the software or of the measurement. You can do that yourself in the Teams window. All right, Greg, all you, man.
All right. Good afternoon, everybody. My name is Greg, CBL Technology Development Director with AccuCheck. What you're seeing on the screen is what I'm seeing live on my PDA screen of the GapGun Pro2. In the camera is obviously a live view of what I'm going to measure. We're going to take 10 measurements today of this engine casing, 5 with the handheld GapGun Pro2 data collector, and 5 additional different measurements with the AccuCheck Vectro 2 system with the T15 sensor. So I have a carbon fiber tip attached. The sensor doesn't know if the tip is attached. It's used as a guide. I'm going to pull this trigger, and my violet laser with 2,500 data points is live, and you'll see I'm best fitting a radius into that concave area. And the sound and the green bar indicate that I was in spec to the upper and lower spec limit shown in parentheses. My next feature, I'm going to pull the trigger, is a break edge, in which I'm not only trying to best fit a radius, but I'm showing what's above and below the spec limit CAD lines. Not sure if you heard it, but there's a different audible tone, and it's showing we do have data above the upper spec limit for that measurement. So now I'm going to switch over with the head extension cable. The cable allows me to get more confined regions, or it also allows me to more easily see where I want to measure. So it's a quick disconnect, can be hot plugged. You'll notice there's also, in addition to the trigger, a button that I can press that acts like the trigger that initiates the measurement. So I'm going to measure this feature here, which is actually a compound feature. The T15 longer generation laser line allows me not only to pick up the radius, but also we're best fitting a chamfer 3-line fit. And we're just like we did for the previous radius, we're showing any data that's above or below the upper or lower spec limits. That larger laser line also allows me to pick larger features. For instance, this radius, which measures almost about a 1/4 inch. For our final feature, we have another break edge. There's a series of holes that surround this part, and we're going to measure this very small break edge here. And we're not looking at the radius, but we're looking at any data that fits above or below. Because I'm set up wirelessly right now, we can actually update this data without plugging anything in, and we get a summary beforehand that's showing what was measured, what was in and out of spec. And if I pull the trigger again, I can upload this data, which you'll see momentarily will automatically generate 2 reports. The first report is an Excel report, very simply made. It's showing where we measured, as well as the characteristic for that measurement, the value, and the deviation from nominal. The second report is a more graphical view. It's showing not only where was in and out of spec, but also where that measurement was collected and how the sensor was positioned across that sensor, indicated in the circle and triangle. In reality, we can upload the data to any data textual-based, ASCII-based format. And that's one thing AccuRex does provide as a service when the system is sold. In addition to getting the report, we can also, as a diagnostic stage, maybe we want to find out why that measurement was 69 thou, we can open up SPC 3D and view each one of those profiles. So the profile here was 69 thou. We're in spec. We have another measurement here that we're showing that was measured out of spec. Here's our CAD lines. So we're showing data that were 0.006 of an inch above the upper spec limit. So these purple lines indicate a boundary. So we expect all the data, the digitized data, by the way, the gray, just like the blue here, represents the material side, must be in spec, has to fit between these upper and lower boundaries. That longer laser line, the newest generation, also allows us to not only measure a couple of features together. We have a radius, and to the left of that, we're looking at the boundary lines of the chamfer and our larger radius. And our final feature for the handheld measurements was a break edge feature again, where we're trying to, this one is obviously in spec, but we want to make sure all of our edges fit into this confined region, which we can define in a region of interest and a buffer zone. So for the next part, I'm actually going to stop sharing momentarily here, and we're going to disable the camera momentarily. We're going to reset our configuration and move into measuring with the AccuCheck, which is a home root solution, software and hardware, using a universal robot to automatically collect the break edge measurements. So let me just give us a quick moment here.
So while Greg's doing that, I'll just reiterate what he mentioned earlier, is that the data transfer, if you perform measurements on the GapGun and you want to put those into your quality system, whatever that may be, that process can be customized. So the graphical and the textual examples they show were just to show that, hey, you upload data and that happens automatically. But again, that can be custom tailored depending on the needs of a given environment. And the same with when we show the SPC 3D software, that's kind of the administrative tool, but it's really powerful not only for the data transfer, but for configuring inspection plans. So it wasn't really that evident on the GapGun when we were going through it, but you can set up, essentially little work instructions on the GapGun that will step through and tell, you may have 50, 100 places you want to inspect on a part, and the GapGun will just step through and say, okay, measure here, then measure there. You can have a picture showing where you're measuring. Each inspection point can be tailored as needed. So a lot of power in making sure that it's set up and doing exactly what you want. All right, Greg, I'll shut up now.
Oh, no worries. So now what you see live in your camera view is the Universal 5E robot with the T15 sensor as an end effector. And what you see in the shared screen here is the AccuCheck software, developed in-house as a solution to use the rotary stage, automated rotary stage, the robot, and the T15 to collect break edge or gap and flush measurements. So I'm going to pick my part here, and I'm going to define a serial number, similar to what we would do with the handheld. And once I press play, the robot will move into position and collect a measurement on various 5 locations. So you'll see, just like before, the green LEDs will indicate that the system is in range, and the laser line stripe is across that data. I'm not sure if you heard
Greg, I don't see your screen share for the robot here.
I apologize. Thank you, Paul. So we're actually on the 3rd measurement already. I apologize for that. But on the left-hand side, you see the profile being collected. The upper right-hand side is the inline view. That's showing where that data was collected in a conditional formatted pass or failed a given set of tolerances. In the bottom right, we see previous runs of that data collection, also in a conditionally formatted And you can see we have various features here. Feature 3 was a break edge where we're looking at the radius and the upper and lower spec limit. Feature 1 was a chamfer. Feature 4 was a combination of a chamfer and a radius. And you can see here, this was a double radius, an S-shaped curve, in which we're measuring a small radius and a larger radius. And you can see our smaller radius was 21 thou and our larger one was 121, both of those in spec. Now that that's complete, we can run a different part, or we can go into SBC 3D, just like we did with the handheld, and view the results. That data can be sent, again, to Excel. It can be sent to a PDF, various formats. But what we'll see, similar to before, is we have a chamfer measurement here. We're measuring the leg length on the left and the leg length on the right. They happen to be symmetrical in this case. Our radius was smaller than nominal. I think we were expecting a 25 thou. We got an audible tone and we're indicated in red, as it was with the AccuCheck software. And our upper and lower spec limit, we very slightly above that upper spec limit here for that small radius edge surface. And we have another feature that's a compound feature with a larger radius and a small leg length on the right-hand side of that chamfer. And we just saw this final feature here. So this software, like Paul had mentioned earlier, we can mask out where we want to collect the data, where we want to inspect the data, set our upper and lower spec limits, define our features, define our graphical information to the operator who's inspecting the part as well. And that pretty much concludes the live demonstration of that. I appreciate everyone joining us today.
Great, thanks, Greg. Since why don't you go ahead and run that robot again real quick, and I'm going to switch to sharing my screen here. If anybody has any questions they would like to submit, you can type them into the question and answer thing there. There we go. If anybody has questions they don't want to submit in the thing there, but they just want to reach out to AccuRex to get more information about that, about our technologies, then we suggest you reach out to info@accurexmeasure.com, or just you can call our office 610-544-1006. Believe it or not, we have humans answering the phone, no AI and no phone system. So yeah, you can give us a call or an email if you're interested in learning a little bit more about that. The one question that that we always get has to do with the accuracy of the GapGun. So I'll go ahead and there you go. So you know, the GapGun, as I said, it's ISO 17025 certified device. So you know, it's got very specific requirements about specifying the performance. So they've got these artifacts. They've got different size radii and different size chamfer artifacts that they're you know, used to specify this. So the whole table gives you the information about the bias as well as the repeatability of the measurements. But the bottom line is you're looking at a bias of about 6 thou in all cases. Or, excuse me, not 6 thou. Excuse me, 6/10. That's an important difference there. Yeah, the excuse me, 6. Yeah, there you go. So 0.0006, 6/10 thou for the GapGun. And again, that's specified performance. And the important thing is that it can really be configured very tightly and flexibly to handle all the different types of range of things that people are going to encounter. So let's see if I'm going to stop sharing this and see if there's anything else in the Q&A. Okay. So there's a question, can the GapGun do GapGun flush? That is a very good question. Yes, that is in fact the genesis of the name of the GapGun. So yes, the GapGun does do gap and flush measurement. It's just a simple matter of interpreting that laser line a little bit differently. So within the GapGun, you've got what we call a whole set of tools, which are the algorithms for how it interprets the line. So you've got some for chamfer, some for radii, but you can also measure gaps and steps and mismatches and you know, a host of other things that you can pick up from that profile. So question, does the use of the cobot increase accuracy? It's a good question as well. It doesn't increase the accuracy of the measurement, but it can increase the repeatability. Okay, so the only variable of the operator really is when they position that gap gun is how are they oriented at the feature, and you know, and you know, are they stable, right? So with the robot, it's going to go back to that same place every time. You can even see in the thing that the robot, you know, there's the turntable being moved. So between the turntable and the robot, we can make sure that the sensor orientation of the part is very consistent. So that very helps with our repeatability of the measurement. Smallest arc radius the system can measure. This is a question that's dangerously close to launching into my long speech about radius measurement in general. But so we can extract a radius measurement from, you know, there's not really a limit in terms of the size of the arc, but the problem is from a metrology standpoint, there is, right? So if you start talking about an arc of 10 degrees, then there's just not enough there mathematically to get a good repeatable radius measurement. I actually have a paper from NIST that I sent out to people to prove that it's not a measurement problem, it's a metrology problem, but or it's not a device problem, I should say. But anyway, so we generally say you want to have at least 45 degrees more than that to do a radius measurement, but you can also just look at the profile for some of these complex curves. We've only got a small segment of a certain radius. You can look at a profile and compare that as opposed to trying to fit a radius to something that's not reliable enough for good measurement. Calibration process for the system, someone asks. So actually, it's a very good question as well. The sensor itself comes from the factory, calibrated, as you saw the specifications to show what it matches. It's also delivered with calibration artifacts. So, you know, pin gauges for radius, or you know, step and gap gauges for gap and step measurement. So these are certified artifacts, and there's a routine on the gap gun where you can perform essentially a recertification at any time. So generally speaking, the gap gun doesn't have to go back to the manufacturer for calibration unless there's damage. Most of the time, if you know, different customers have different processes for how frequently they want to validate the calibration, but as long as your artifact is, you know, current and has been certified within the time period of your calibration, or excuse me, of your quality system, then you can essentially perform your own recertification of that gap gun performance. How well does it work on plastic parts? That's a good question as well. So I didn't even mention it, but what we were showing there was the T15M, where the M stands for metallic. So the gap gun sensor, that one is tuned to handle metallic reflective surfaces that have been machined. If you have plastic surfaces, the only difference you would make is you would use a T15V, which just use it's the same architecture, same sensing, but there's a little bit less inside, so that we can get a stronger return on plastic parts. So it works quite well on plastic parts. We would just do some testing to find out what's the appropriate sensor configuration, you know, for your materials. Okay, that looks like most of the questions, which is perfect, because I think that puts us right at almost 30 minutes. So I guess that looks like the end. Again, I'm going to put that back up, info at AccuCheck measure for your, let's see. Of course, I'm showing the wrong page here. All right. Well, anyways, there it is. Hey, info at AccuCheckMeasure.com or 610-544-1006 to reach us if you think of questions after we finish up here. Again, I'd like to thank everybody for your time. Thank you, Greg. Yeah, we will have this available. We're going to send out a copy of the recording to all the attendees as well. And again, thank you for your time and attention today.